I don't want to target attack anybody, but some of you currently watching this TikTok acting like you don't have priorities. Just because we're going through a pandemic doesn't mean you don't have homework tomorrow. You're scrolling through your For You page when you should be scrolling through your textbooks. You're worried about Addison Rae. You need to be worried about adding and subtracting.
Today in math, we're practicing more of the same thing. We are dividing. So we're going to be making that T-chart, finding what number is closest to the dividend, and dividing it up. So again, first we're just going to do a division problem outside of a word problem. So just straight up division problem. 1,955 divided by 85. And we're going to use partial quotient to solve it. 1,955 divided by, I'm going to make that big 7, 85. All right, so I am going to make a T-chart for 85. Got a big divisor here. All right, so yes, unfortunately we have to count by 85, but I have a feeling we're not going to have to count very far. So 1 times 85, 85. 2 times 85 is, 5 plus 5 is 10. Carry the 1, 170. And then 3 times 85, 5. 8 plus 7 is 15. 2, 55. All right, I have to stop right here because 255, if I add a 0 to the end, will be way too much. I'm trying to get close to 1,955. So the closest I can get is times 2, which in the end, it won't really be times 2 because we have to add that 0. So that's 170. I need one more 0, and that will be times 20. Now I can subtract. And I have 5, 5, 2 left over. Okay, now I already have this in my chart. Boom. Times 3 is 255. And I subtract and I have nothing left. So my answer is 20 plus 3, 23, remainder 0. Okay, moving on to the next problem. There are 18,450 headphones that need to get boxed for distribution. Each box can hold 21 headphones. How many headphones will not fill a complete box? Okay, let's stop and think about what it is that they're asking. Because I don't think they're asking us to just divide and give the quotient. So they give us a certain amount of headphones that they have, and they say that each box can hold 21 headphones. So we are splitting 18,450 into groups of 21. And the question is not how many boxes will there be. The question is how many headphones will not fill a complete box. So they're asking for the remainder. They're saying how many will be left out and not fill a complete box. So that is the remainder. So in order to find the remainder, yes, you have to find the quotient. You have to solve it. So that's what we're going to do. All right. So I'm going to write my big 7. I have 18,450 divided by 21. Okay. Now what do we got to do? Make a T-chart. Make the T-chart. So I'm going to make a T-chart for my divisor. A T-chart for 21. So I'm going to be counting by 21. Now I'm not going to try and count to 20. I'm not going to try and count by 21 until I get this big answer. I saw people trying to do that before. You want to find something close to it by using what you already know about multiplying times this number. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I'm going to write to 10 just in case I need to go that far. I don't think I will, but I know times 10 is going to be 210. Times 1 is 21, and I'm going to fill in the rest. Well, actually, I know half of 210 is 105, so that would go there. Okay, so if I know times 5 is 105, and I'm trying to get close to 18,450, meaning I want to get close to probably 184, and then just add zeros. Then I'm going to start after times 5 because I can still get bigger than this and get pretty close. So I'm going to start adding 21 after this. So 105 plus 21 would be 126. Plus 21 would be 147. Plus 21 would be 168. I can still go for more. Plus 21 is 189. All right, now that I went too far there. So closest I can get without going over, and again, I'm just looking at the first 3 digits because I know that I can just add zeros. Closest I can get would be times 8. And that's 168. 168. But I need to add 2 more zeros because I have 2 spots to fill. So if I add 2 zeros here, then I add 2 zeros here. And so now it's times 800. And I can subtract. Okay, 0 minus 0, 0. 5 minus 0, 5. 4 minus 8, oop, can't do that. Have to regroup. So that's 7, and now that's 14. 14 minus 8 is 6. 7 minus 6, 1. And 1 minus 1 is nothing. Okay, now, again, I want to get close to this number. But times 10 is 210. So again, I want to think about if I add a 0, what will be close? So the closest I can get without going over would be times 7, because times 8 is too much. 168, that's too much. That's 165. So times 7 is the closest I can get, which we know won't really be times 7, but that's where we start. And now I need one more 0. If I add a 0 here, I'm going to add a 0 here, and then I subtract. 0 minus 0, 0. 5 minus 7, can't do that. Have to regroup. So that's 5. Now that's 15. 15 minus 7 is 8. 5 minus 4 is 1. Okay. 180. If I look at my chart, okay, times 9 is 189. That's too much, so I got to do times 8 again. And that will be 168 when I subtract. Okay, 0 minus 8, can't do that. Have to regroup. How this is 10. 10 minus 8 is 2. 7 minus 6 is 1. And 1 minus 1 is nothing. So, going back to the original question, they asked, how many headphones will not fill a complete box? So my remainder is my answer. And my remainder here is 12. So 12 headphones will not fit in a complete box. I know that was a long problem, but sometimes you just gotta do what you gotta do. Okay, now this is the problem you are going to be solving and then writing the answer in the comments. This time I'm not going to even make the T-chart for you or set up the problem for you. You got to figure it out on your own. I will read it though. It says, Aaron.
Hey, Aaron, where are you? Where is Aaron right now? No Aaron, huh? Well, you better be sick, dead, or mute, Aaron.
Here? Oh, man.
Why didn't you answer me the first time I said it, huh?
Huh?
I'm just asking, I said it like 4 times, so why didn't you say it the first time I said Aaron?
Because it's pronounced Aaron?
Is solving 1,350 divided by 90. He needs your help. Show him how you would calculate this quotient. Circle your final answer. All right, short, simple, to the point. Divide it. Tell me the quotient. Quotient means answer to a division problem. So just give me the answer, people, and write it in the comments. And finally, we have your exit slip, which we all know you can find on Canvas. Remember, you must send me a picture or upload the picture to Canvas. If you don't know how to upload it, text me the picture, please. Thank you.
Ready for more stargazing? Last time we talked about constellations, clusters of stars in the sky that appear together in a particular pattern and have been given a super cool name like Draco or Hercules or Pegasus. And you might also remember that astronomers can use constellations to help them find objects in the night sky. After all, a big shape in the sky made of lots of stars is way easier to find than a single sparkly dot. But what if the thing you're trying to spot is a constellation? Are all of the constellations always visible in the sky from everywhere on Earth? Nope. To understand why, let's see how constellations appear to move across the night sky. For one thing, the constellations that you can see depend on where you are on the Earth when you're looking. People above the equator in the northern hemisphere see different constellations than people below the equator in the southern hemisphere. For example, this is Ursa Major, or the Great Bear constellation. Ursa Major is visible high in the sky in most parts of the northern hemisphere. And this is Crux, sometimes called the Southern Cross, the smallest of the constellations. Crux is highly visible in the southern hemisphere. So why is Ursa Major not as visible below the equator and Crux not as visible above the equator? Well, the Earth is round and rotates on a tilted axis, so certain parts of the world have better views of certain constellations than other parts do. Observers at the North Pole, for example, can really only see constellations that are visible north of the equator. They can't see the ones below that because the Earth is in the way. But if you're lucky enough to live near the equator, you can see all the constellations over the course of a year, which brings us to another point. The constellations that you can see don't just depend on where in the world you are. It also matters what time of year you're looking for them. To see why this is, let's take a look at Earth from space. Hey there, home planet. Here's the sun over here, and all those twinkly things are stars and constellations. You'll notice the right side of the Earth is darker than the left side. That's because it's nighttime on that side of the Earth. So people on this side of the planet have a great view of the stars and constellations over here. As the Earth rotates on its axis, whichever part of the planet is facing away from the sun has a great view of these stars during this season. Let's say it's winter if you're in the northern hemisphere and summer if you're in the southern hemisphere. But as you know, the Earth isn't just spinning on its axis, it's also revolving around the sun. So as the Earth moves around the sun, the seasons change, from say winter to spring, or in the southern hemisphere, summer to fall. And as the seasons change, so do the constellations that are visible at night. So several months later, you're now seeing these stars in this part of space. And as the Earth continues around the sun, the seasons change from spring to summer, or fall to winter in the south, and these stars are now visible to us at night. And finally, as that season fades and the Earth continues its path around the sun, giving us this group of stars. So, where the Earth is around the sun affects what season it is, and therefore what constellations are on display in the night sky. And that helps us tackle our big question. How do the constellations appear to move across the night sky? Their change in position during the night and over the year is actually a result of the Earth's motion. Depending on where in the world you are and when you're looking, different constellations will have moved into view in the night sky. What constellations are visible where you live this time of year? To find out, just grab a few friends, maybe some nice hot chocolate, and wait for dark to do some serious stargazing.
Science today is going to be very short, simple, to the point. We're talking about stars and why stars appear to move across the sky. We know that they don't actually move. The sun is not moving. It appears to move. When we look at the sky at night, the stars appear to move. It's your job to remember why or find out why if you don't remember. Google it. Also, remember, in class, we did this activity where you got up. Some of you went to the spring constellation. Some of you went to summer, fall, winter. And then you revolved. You revolve the way around. You revolved around the sun, and you were able to see different constellations at different times. Hint, hint. Cough, cough. That's going to help you answer the Canvas questions. So, what does it look like on Canvas? This is what it looks like on Canvas. On Canvas, you're going to look for today. It says Wednesday, Science Mission 4/29/20. You click on it. And yes, I have to show people how to do this still. Oops, I don't want to give you the answers. All right, so it's going to be, I think I cut it down to only 3 questions, so you're lucky. You look at the diagrams they give you, you answer the question, you type it in. Read the question, type it in. Look at the diagram, read the question, type it in. Press submit. It's going to say that you got them all wrong because I have to go in and grade them. Alrighty, folks. That's all. Bye-bye now. Ta-ta. Do all your work. My grades are due today. There is no way that you can turn anything in after today from all the weeks before this one. So if you don't turn it in now, it will be an F. ASMR. An F. Okay, so yeah, it will be an F. So please, if you haven't done that, that's your number 1 priority. Thanks. Bye-bye now.